positive direction. So that's correct also. So B and D. Okay, so now number 9, we've got object 2 and object 1. They're traveling across a horizontal surface, and the horizontal velocity function of time is shown. And we're looking for one statement that's true about this system. So A says the magnitude of acceleration is greater than magnitude. So magnitude just means size. So we're looking at the value, not the sign. So if this goes from 40, let's just do the first second. So this has a slope of -10, and this has a slope of +10. So the magnitudes are the same. So that's not true. After 2 seconds, so from this point onward, the object 1 travels a greater distance. So distance is the area. So for this object, the area is this. And for the other object, for object 1, the area is that. So that's true. Look how much bigger that area is than that one. So that's true. Let's just read over the rest and make sure. Object 1 and 2 are at the same position at 2 seconds. Well, that's not true because you don't know where they start or anything, so that's impossible to tell. After 4 seconds, the speed of the object is greater than the speed of object 2. Well, we can see that at 4 seconds, we know that this has a speed of 40 and this has a speed of 0, but we don't know what happens after that time, so we can't make that assumption. So number 10 says an object is, let me make sure we can see that. Okay, an object is dropped from the top of a building near the Earth's surface after 2 seconds. A second identical object is also dropped. And you can see these are both dropped objects. This one is dropped later. They have the same slope, which makes sense because they're both in free fall, so they're both going to have an acceleration of 10. If they were talking about a 2-system object, the accelerations are both equal to -10 meters per second squared. So yeah, so this has to be the approximate acceleration of them both. And that's it.